When was the last time you stopped to think about how electric cars actually work? How does an electric car motor work? In an electric vehicle, when the driver applies the accelerator, the battery in the car supplies electricity to the stator, causing the rotor to turn, and subsequently provide mechanical energy to turn the car's gears. Once the gears are rotating, the wheels turn too. All this happens in the blink of an eye, and without fossil fuel combustion. There are two types of AC electric motor used to create traction for an electric vehicle: asynchronous, aka induction, and synchronous. In an asynchronous, or induction, motor, the rotor is pulled into a spin, constantly trying to catch up with the rotating magnetic field created by the stator. This type of electric car motor is known for its high power output and is a common motor in vehicles. In a synchronous motor, on the other hand, the rotor turns at the same speed as the magnetic field. This provides high torque at low speed, making it ideal for urban driving. Another advantage is its size. A synchronous electric car motor can be compact and low weight. Electric vehicles now include cars, transit buses, trucks of all sizes, and even big rig tractor-trailers that are at least partially powered by electricity. Electric vehicles fall into three main categories. Battery electric vehicles are powered by electricity stored in a battery pack. Plug-in hybrids combine a gasoline or diesel engine with an electric motor and large rechargeable battery. Fuel cell vehicles split electrons from hydrogen molecules to produce electricity to run the motor. Unlike gas-powered vehicles, electric vehicles do not require internal combustion engines to operate. Outfitted with an electric motor and rechargeable battery pack, electric vehicles move along our roadways without burning up gasoline or producing harmful exhaust emissions, while generating less noise pollution. Here's a basic rundown of how electric cars work. EVs receive energy from a charging station and store the energy in its battery. The battery gives power to the motor which moves the wheels. Many electrical parts work together in the background to make this motion happen. Key components of an electric car. Breaking down the key parts that make up an electric car is essential to understanding how they run. These key components include charge port. An electric vehicle's charge port allows the battery pack to receive energy from an external power source. These power sources are referred to as electric vehicle supply equipment, more commonly known as a charging station. Charging occurs when an electric vehicle supply equipment is plugged into an electric vehicle's charge port at a private residence or commercial charging station. For example, an electric vehicle supply equipment that utilizes a standard 240-volt outlet, similar to those used for household appliances, can charge an electric vehicle overnight. Inverter. Electric vehicle inverters change the battery pack's flow of electrons from a direct current DC, into an alternating current, AC, which is then used to power the electric traction motor. Because lithium-ion batteries can only accept DC power, and because electric traction motors require AC power to function, inverters are necessary components for electric vehicles. Inverters are also used to control the frequency of the AC power being sent to the motor, so they play a direct role in controlling an electric vehicle's speed. Electric traction motor. Receiving electricity from the inverter, the electric traction motor provides the power that makes an electric vehicle move. Electric traction motors are commonly powered by an alternating current, as this type of motor is more efficient and reliable than a DC motor. When AC electrons reach the motor via the inverter, they generate a rotating magnetic field that causes the motor to turn. Electric traction motors are highly efficient and powerful, as they do not feature multiple gears to shift between like an internal combustion engine. Power from the pedal to the engine is almost immediate. Traction battery pack. An electric vehicle's traction battery pack's main function is to store energy gathered from the grid during charging. This energy is then used to power the vehicle's motor and all other electrical components. Almost all electric vehicles on the road today utilize lithium-ion batteries within their traction battery pack, as they have one of the highest energy densities of any battery available. Lithium-ion batteries also produce larger currents and require little maintenance compared to other battery types. Some electric vehicles also feature an auxiliary battery that strictly powers vehicle accessories rather than drawing from the traction battery pack to power all components. Electric powertrain. An electric vehicle's powertrain encompasses the entire high-voltage electrical system that allows the vehicle to operate. An electric powertrain is commonly made up of an inverter, electric traction motor, reduction drive, and the traction battery. These electric powertrains are lightweight, compact, and provide very little vibration with instant torque. Many inverters in electric powertrains can even recover displaced energy during deceleration. This process is known as regeneration, transferring unused AC power during braking into DC power that can be stored back in the battery pack.